Hello students, in this video we're going to apply the R formulae to solve some problem sums. We'll be doing some questions from exercise 11.5. Right, let's do a recap of what the R formulae are all about. Right, so you may be presented with questions in the form A cos theta plus B sin theta. A and B are positive values, so it could be like 2 cos theta plus 3 sin theta, or you could be given A cos theta minus B sin theta, or A sin theta plus B cos theta, or A sin theta minus B cos theta. So for each variations, then the R formula that we need to apply will be different. So for example, like A cos theta plus B sin theta, we can let it equals to R cos bracket theta minus alpha. And if it's given that A cos theta minus B sin theta, we can let it equals to R cos bracket theta plus alpha. Likewise, if you have A sin theta plus B cos theta, in this case here, then we'll be using R sin bracket theta plus alpha. The last one is if you're given A sin theta minus B cos theta, then the R formula that we'll be using will be R sin bracket theta minus alpha. Okay, so remember that the formula to find R will be, okay, and to find alpha will be tangent inverse B over A. Okay, take a note of the sign in the middle. Right, so for cosine, you see that if we started with A cos theta plus B sin theta, then the R formula is R cosine bracket theta minus alpha. Okay, that it's the sign are not the same. However, for sine, if you are using A sin theta plus B cos theta, then you'll see that there's no change at all. Why is that so? It's because our formula, if you were to recall, is derived from the addition formulae. Okay, it's derived from the addition formulae. So if you've already forgotten how the addition formulae looks like, just do a recap on it and you'll understand why. That there is a difference in the sign when you use R cos versus when you use R sin. All right, so let's look at the first questions. You're asked to express each of the following as a single trigonometric functions of angle theta in degrees. Right, so if you look at 1a, there are two different trigo functions, sine theta and cos theta. Right, so we need to express it as a single one. Okay, so we're going to compare it with, if you do recall the earlier slides, right, there are 4 columns there, right? So this sine theta plus cos theta will be comparable with A sine theta plus B cos theta. You can compare this with your A sine theta plus B cos theta. So you remember the R formula that we'll be using here will be R sine bracket theta plus alpha, right? Okay, so from there we can actually write down the values for A. A is the number in front of sine theta. This case here is 1, and B is the number in front of cos theta. In this case here is also 1. Okay. Right, so you can just substitute into the R formula, which is equals to the positive of your A, what positive is positive? R is equals to positive A squared plus B squared. So that will give you square root of 1 squared plus 1 squared, which is give you square root 2. And alpha will be tangent inverse B over A, okay, which is 45 degrees. Okay, so we put them together. That will give you square root 2 sine bracket theta plus 45 degrees. Okay, this is what it means. Okay, you put them together using the R formula. Okay, to get the single trigo functions. Right, so for B, okay, if you to remember, for B, we will have to compare this with the R sine theta minus alpha, right? Okay, then A will be half, B will be square root 3 over 2. So from there, you can just plug into your R equals to square root A squared plus B squared, which gives you R equals to 1, and alpha will be tangent inverse B over A, which gives you square root 3. Tangent inverse square root 3, it's a special angle that gives you 60 degrees. So you put them together, will gives you R, which is 1. So 1 times sine bracket theta minus 60 degrees will give you just sine bracket theta minus 60. Okay, so questions 1, it's pretty straightforward. Right, let's look at the next questions. If you look at 1C, okay, I'm going to show you the incorrect way of doing. Right, what is the incorrect way of doing? All right, so why is this incorrect? First of all, your values for A and B have to be positive. Right, so in this case here, you see that you're letting your A to be negative pi, which does not agree with the rule to apply the R formula. And also, if you look at the alpha you're getting is negative 45 degrees. But so far, we have understood that alpha, it's the reference angle or the basic angle. Okay, we need to use it because we're using the concept of ASTC. So alpha has to be a positive acute angle. All right. Therefore, when you are faced with these questions in this form, you can't just straight away apply the R formula. So the correct way is we have to factorize on negative pi. Okay, factorize on negative pi, and you see that now you have a positive sine theta. A is positive already, and B is also positive. Right, then this one here, you can apply your R formula to be equals to R sine bracket theta plus alpha. Okay, so from there, your A is 1, B is 1. So R will be square root of 1 squared plus 1 squared. That gives you 2. So R equals to square root 2. So alpha will be just be tangent inverse B over A, which is tangent inverse 1, gives you 45 degrees. Right, then you putting them together. Okay, this is how you do this question 1C. All right, you have to factorize your negative pi out. Okay, so the negative pi is here. This is the single trigo function for your sine theta plus cosine theta. And then if you take negative pi times square root 2, that will give you negative square root 2 pi and then sine bracket theta plus 45 degrees. Okay, if you look at part D, we don't have such problem. Right, this one, you can just apply equals to R cosine theta plus alpha. Right, so this one have no problem. So the A will be just square root 2 and B will be just 1. So you can find your R, find your alpha, and then put them together back into your single triangle function. Okay, for final answer should be 1 decimal place for angle. This is 2 decimal places because it's in between answer. Okay, so for part E, right, the way to do it is still the same. P sine theta plus K cos theta. So the values for your A will be P, the values for your B will be K. Okay, and then yeah, so your R will be in terms of square root of p squared plus k squared. Then your alpha will be tangent inverse k over p. Right, so you put together as a single trigo functions. Okay, this is how you present it. So this question is the concept is no different from what we have done earlier on, just that in this case here the values for a and b are expressed as a variable, not as a number but as a variable. So your alpha is also expressed as a tangent inverse of a variable k over p. All right, let's look at the next questions. So the next questions is similar in concepts to the first question because we need to express this as a single trigo function using the R formula, except that after expressing it as a single trigo function using R formula, we need to find the corresponding values of y, the maximum value of y, and the corresponding values of theta. So this part here will need you to recall your cosine curve and your sine curve. Right, so let's take a look at the sine curve first. Right, this is how the sine curve looks like, right? And the maximum y value will be 1, right? Minimum y value will be -1, right? And that happens, maximum y value is 1 that happens when the angle is 90. Minimum -1 happens when the angle is 180 degrees. This is for y equals to sine x. But of course, your x can be bracket x minus something or x plus something, right? But the maximum minimum value for y is still 1 and -1, no change. Then for your cosine curve, this is how it looks like for your cosine curve. So the maximum value happened at 0 degrees and 360 degrees. Then the minimum value happened at x equals to 180 degrees. So this is for y equals to cosine x. Okay, so this is a very, very important information that you have to take note of. Okay, so we're going to do part A. Right, so part A, right, so we just let 3 sine theta plus 4 cos theta equals to r sine bracket theta plus alpha. Then from there you can read off your A to be 3, B to be 4, can find your R to be 5. And then your alpha to be tangent inverse 4 over 3. Okay, so as a single trigo function, this is what happened. All right, so based on just now what we have discussed earlier on for this sine curve, I shouldn't have drawn my cosine curve there. Never mind, later I will just draw it again. It's so confusing. Okay, let's draw your cosine curve again. Never mind. All right, so for your sine curve, let's do it again. This is how your sine curve looks like. Maximum y value is 1, that happens when your angle is 90. Minimum y value is -1, happens when your angle is 270 degrees. This is y equals to sine x. Right, so therefore the maximum value for this will be 1. So maximum value for y will be 5 times 1 gives you 5. Cut. Okay, never mind. Cut into my diagram again. All right, and that happens when to get maximum y value to be 1, that happens when the angle theta must be 90. So theta plus 53.13 degrees must be equal to 90. And therefore theta is 90 minus 53.13 gives you 36.9. Okay, because when you substitute your theta to be 36.9 plus your 53.13, you will get 90 degrees. And sine 90 is 1. Okay, right, so for part B, all right, we're going to express it as a single trigo function using the R formula. Okay, so for cosine curve, This is how your cosine curve looks like. Huh? So the maximum value of y happened at x equals to 0 or 360. Minimum value happened at x equals to 180. Right, so in this case here, this has to be 0 degrees. And if that is 0, then theta will be 22.62. Okay, express the one decimal place will be 22.6. Then how about 360? Yes, if it's 360, then you realize that theta will be equals to 360 plus 22.62, right? And you see that this answer we're going to get will be out of my range because my theta has been between 0 degrees and 360 degrees inclusive. Okay, so therefore even though cosine 0 gives you 1 and cosine 360 also gives you 1, we only accept this answer because this is within the range. This answer is out of the range. Right, let's look at the next question. The next questions require us to find some maximum value of y and the corresponding value of theta. Right, so let's look at question C first. Right, so you're given y equals to 1 over 3 sine theta plus 4 cos theta plus 12. Right, so we will need to express this 3 sine theta plus 4 cos theta as a single trigo function. So for that, we will have to apply the R formula. Okay, so we're going to let 3 sine theta plus 4 cos theta equals to R sine bracket theta plus alpha. From there, we can see that A is equals to 3, B is equals to 4. And we can substitute into the R to find R equals to square root of 3 squared plus 4 squared to get 5. And alpha will be tangent inverse B over A, which gives you 53.13 degrees. So therefore, your y can be expressed as 1. Okay, wait. So therefore, your 3 sine theta plus 4 cos theta plus 12 can be expressed as 5 sine bracket theta plus 53.13 degrees plus 12. Okay, so the minimum value, now, just take note that, let's look at these two fractions, halved and 1 over 0.5. You'll see that 1 over 2 is 0.5, but 1 divided by half will actually gives you 2. So if you want the fraction to be big, because obviously 2 is bigger than 0.5, right? Then your numerator, okay, has to be small. Okay, if you were to compare 2 and 0.5, of course 2 is greater than 0.5. So your numerator has to be very small so that if you want your fraction 1 over that very small number to be a bigger number. So if you want to find the maximum value of y, what we are saying is that we want this value here to be small. So therefore, the minimum value of 3 sine theta plus 4 cos theta plus 12, which we've already been able to express it as 5 sine bracket theta plus 53.13 degrees. So the minimum value of this, right, will be the minimum value of this sine bracket theta plus 53.13 is -1 plus 12, that gives you 7. So the minimum value of that will be 7. And to get that means, as what I've mentioned earlier on just now, I need this to be -1, right? So sine, if you were to refer to the earlier slide, you know your sine curve, I can show it to you again. The sine curve to get minimum value of -1, that happens when the angle is 270 degrees. So therefore, your theta plus 53.13 degrees must be equals to 270. So that makes theta equals to 216.9 degrees. So therefore, the maximum value of y will be 1 over 7 at theta equals to 216.9 degree. All right, so let's look at part D. Okay. The logic to do part D, or the way to do part D, is similar to do part C. Okay, so first thing first is that we're going to express 12 cos theta plus 5 sin theta equals to r cos bracket theta minus alpha. A is 12, B is 5, phi r, phi alpha. Okay, and express it as a single trigo function. All right, so the minimum value for this will be -1. Okay, and that happened when because cosine 0 will gives you, oh sorry, you want it to be -1. So if you were to refer to the cosine curve to get minimum -1, that is when the angle is 180 degrees. So in other words, this angle must be 180 degrees. So that cosine 180 degrees gives you -1, right? So that will make your angle theta to be 180 plus 22.62 gives you 202.6. So therefore, the maximum value of y will be 1 over half here. We found it here at theta equals to 202.6 degree. All right, let's look at question 7. Similar to what we have done, just that we need to solve the trigo equations. So for first part, we just need to express this as a single trigo functions using the R formula. So we can let this equals to R cosine bracket theta plus alpha. Okay, so A will be 14, B will be 5. Then we can find the values for R, find the values for alpha. Okay, express it as a trigo function for f of theta. All right, and then we're going to solve it. So since f of theta equals to 8, what we're saying is that 14.87 cos bracket theta plus 19.65 degree will gives you 8. All right, so this is a simple solving trigo equation. So you're going to divide both sides by 14.87. Okay, so go back to your ASTC. Your ASTC will tell you that for cosine to be a positive value, it will come from the first and the fourth quadrants. So let's find alpha first. Alpha is a positive acute angle. So alpha will be cosine inverse 8 over 14.87 gives you 57.45 degrees. All right, so your first answer will just be alpha itself. And then the fourth quadrant will be 360 degrees minus alpha. Okay, and that gives you theta equals to 282.9 degrees. Okay, so for part 2, it's similar to what we have done earlier on. Okay, the first two questions, the first, not first two questions, the earlier questions is in question 2. So to find the minimum value of f theta, okay, that depends on the minimum value for cosine bracket theta plus 19.65. The minimum value for that will be -1, right? So therefore, the minimum value for f theta will be 14.87 times -1 gives you -14.9, expressed with 3 significant figure. Right, so for part 3, the concept is the same as what we have done earlier on, finding the maximum value of y and the corresponding values of theta. So for part 3, the question is just rephrased in another way. Okay, finding the least possible value of theta means the corresponding values of theta. Right, so the way to do it is still the same. What do I mean by still the same? Okay, we have already found f of theta to be 14.87 cos bracket theta plus 19.65 degrees, right? So for this value to be minimum, that is when your cosine bracket theta plus 19.65 degrees is -1, right? And if you were to recall your cosine curve to get -1, that is when this angle must be 180 degrees, because cosine 180 degrees gives you -1. Okay, go back to the curve, cosine curve, -1, this angle is 180. So therefore, your minimum least value of theta would be 180 minus 19.65. So that gives you 160.4 degrees. Okay, so the next question asked if it is possible for that f of theta, for the functions to have a maximum value. And it is not possible. Why is it not possible? Because if you're going to substitute, okay, if you look at your cosine curve, right, you can see that there are two values here. The two angles will give you 0. One is cosine 90. Cosine 90 will give you 0. And cosine 270 degrees will also give you 0, right? So therefore, there are two values of theta that will make our f of theta equals to 0. Because if this is 0, if this is 0, 0 multiplied by 14.87 will give you 0. So that's when your f of theta equals to 0, right? So the two values, yeah, it is not possible. Okay, we're going to explain why. So therefore, the two values that I've just mentioned that will give you f of theta equals to 0, that is when this is 90 degrees and when that is 270 degrees, right? So one value will be 90 minus 19.65. That gives you 17.35. The other values will be 270 minus 19.65, give you 250.35. So these two values, when they substitute here, will give you cosine 90 and cosine 270. And that will be equals to 0. So 0 times 14.87 will be 0. So if f of theta is equals to 0, then 1 over 0 is undefined. Right, so therefore that it is not possible, okay, to have a maximum value for 1 over 14 cos theta minus sine theta, minus 5 sine theta. Okay, let's look at the next questions. All right, again, it's similar concepts, just that if you were to look at the questions carefully, we're dealing with double angle. Okay, instead of dealing with cos theta and sine theta, we're dealing with double angle. And if you look at what we are supposed to express it, it's, you know, okay, if you have a cos theta minus b sine theta, right, you can express it as r cosine bracket theta plus alpha, right? So, but if you have a cos 2 theta minus b sine 2 theta, then you can just express it as r cosine, instead of theta will be 2 theta plus alpha. That's all. Okay, nothing very what do you call that? Different. Okay, it's just that the instead of having 1 theta, you know, you just change it to 2 theta lah, or 3 theta, the 4 theta, that kind of thing. Okay, right. There's nothing really scary about it. Okay, so that's how do we do it? Yeah, so we're going to let it equals to r cosine bracket 2 theta plus alpha. So a is still 3. Not a is not still, sorry. A is 3, b is 4. So we can still find r using the same formula, which is square root a squared plus b squared. Okay, that gives you 5. And alpha is still the same, which is tangent inverse b over a. Okay, but right now the trigo functions will become 5 cosine bracket 2 theta plus 53.13 degrees. Yeah, okay, that's it. Okay, right, then for part 2, you're supposed to solve it. Hence, not solve it. We're supposed to find the values of theta, or supposed to find the correspond. That means find the values of theta that gives you this guy a maximum value and a minimum value. So let's do the maximum value first. Okay, so maximum value of y is 5. And that happened when the cosine bracket 2 theta plus 15.13 is equals to 1. Okay, and we understand that cosine two angle will give me 1, right? Cosine 0 degrees and cosine 360 degrees. Okay, why 720? Because if your theta is between 0 and 360, then 2 theta will be between 0 and 720. So it's possible to have another one more round. So from there, you can just find your theta. So the first answer is rejected because the angle theta must be between 0 and 360. So the two possible angle will be these two. Okay, now let's deal with the minimum value. So the minimum value of y is when this one here is -1. Okay, and to get -1, it means this angle must be 180 because cosine 180 then gives you -1. And remember we says that the angle theta have to be between 0 and 360. So since we're dealing with 2 theta, so it's possible to get 180 and one more round, which is 180 plus 360. 540, is it? Okay. Yeah, 180 plus 360, it's 540. Right. Okay. Okay, this is the second last questions of the assignment, so don't give up. Okay, we're going to complete this assignment very soon. This is a problem sum. It may look kind of scary with so many things down there. All right, but don't worry. Let's do one thing at a time. Let's try to understand the diagram first. So if you look at the diagram, that is made up of a semicircle, and inside the semicircle, there's a trapezium OABC. And this semicircle has radius 7 centimeter, and OA makes an angle theta with the diameter of the semicircle. And you're told that BC is perpendicular to both AB and CO. All right, so we need to explain why is it the length of AB, this is AB, why is it this AB is twice OC? Okay, so we're going to draw a line from O to AB, a perpendicular line. Okay, and can you see that we can actually form an isosceles triangle? So in the topic on angle property in the circle, right, there's one particular property that says that the chord is perpendicular. If the chord AB is a chord, okay, AB is a chord. So if the chord is perpendicular to the radius of the circle, okay, I can extend this line OD longer, then that will be your radius of the circle, right? Okay, if the chord is perpendicular to the radius of the circle, then AD is equals to DB. Okay, and if you look at the diagram, your DB is actually the same length as OC. So DB is equals to OC, and DB is equals to DA. So therefore, AB is equals to 2 times OC. Right. So you can just draw the diagram. Okay, explain by drawing the diagram and then follow up with this explanation. The explanations that I have shown here for you, that OD is the perpendicular bisector of the chord AB. Okay, and therefore, hence your AB is equals to 2 times OC. All right. Part 2, you ask to find the perimeter of your trapezium. So where is your trapezium? Cannot erase. Why cannot erase? Okay, never mind, cannot erase. All right, so the trapezium is OCBA. So basically, I know OA is 7 centimeter. That is the radius of the circle. I need to find AB. I need to find length BC. I need to find OC. Okay, so what I've done is just pluck out your triangle OBC. All right, so why is this angle theta? Okay, because you will see that if this is 90, this will be 90, right? So this angle will be 90 minus theta, right? That will be 90 minus theta. Oh, okay. Don't need to use the 90 minus theta. You can just use alternate angle. You see that these two lines are parallel to each other, so this will be theta, right? And this is isosceles triangle. This will be theta also, right? And using alternate angle again, this will be theta. Okay, so that explains why I have theta here. So I can just use trigo ratio to find sine theta equals to BC over 7. So I can find BC. And then I also can find OC using cosine theta. Because basically I need to find the length of OC, BC. And since AB is 2 times OC, I just take 2 times 7 cos theta gives you 14 cos theta. So add up all these things, then I'll get my parameter. Okay, which is what we're supposed to find, is it? Yes, we're supposed to show that the parameter can be expressed in this form. Okay, so we just rewrite it. Put 7 first. 7 plus 14 cos theta plus 7 sin theta. Okay, arrange it in such a way that because they want you to arrange in such a way that k come first, constant come first, followed by cos theta, sin theta. So you just arrange it as accordingly. Okay, so that's part 2, easy. Right, so part 3. So part 3 is not difficult because we have already done it a few times already in the earlier questions. Basically, you just need to express it in a single trigo function, right? Okay, right. So we just need to express this as a single trigo function using the R formula. So we can let 21 cos theta plus 7 sin theta equals to R cos bracket theta plus alpha. Oh, sorry, theta minus alpha. Yes. If this is plus, it's minus. Yeah, minus is plus. Okay. Then your A is 21, B is 7. So you can find your R. And then your alpha will be tangent inverse B over A. Okay, so you put everything back into your P. So that's it. Okay, then for part 4, it's to find the maximum value of P and the corresponding values of theta. So the maximum value of P, it's when this guy is 1. So that will be 7 plus 22.1 times 1. That gives you 29.1, right? And that happens when this is equals to 1, right? So there are basically two angles that will give you 1. One is cosine 0 degree, right? One is cosine 360 degrees. But you see that I don't need to use 360 because that will give me theta 360 plus 18.4. And if you go back to look at the original diagram, right, it's impossible for angle theta to be more than 360. Your angle theta in the diagram, the angle theta in the diagram, it's basically just between 0 and 90. So therefore, you only need to use 0 degrees. So therefore, theta is 18.4. Okay, if you have stayed all the way with me to these last questions, congratulations. Okay, really, this assignment is I don't know whether it's I'm tired or what, but it's like needs a lot of energy. Okay, needs a lot of energy to do. All right, never mind. So let's look at the last question. So the last question is just to find the maximum minimum value for this. So actually, it's not difficult. Okay, it's not difficult. It's just to understand that what is it we need to understand. Let's look at the explanation. Yes. So where do I get this? Again, it's go back to your basic. Your basic, it's go back to the basic curve. Okay. Okay. So this is y equals to sine x. So the maximum value for y is 1, minimum value is -1. So therefore, sine x is greater or equal than -1, less than or equal than 1. Let's explain this. Okay. Okay. So I'm going to find sine x minus 2. So I'm going to subtract -2 on both sides. Meaning I'm just going to -2 here, -2 here, and -2 here. So that explains this part here. So I would have -3. Okay. And I'm going to square. Okay, so I'm going to square this. So that means I'm going to square -3 to get 9. Let's erase this part because I can't really see. Oh, cannot erase. I don't know why it cannot erase. Okay, so that will give me alright, this part here is not clear, so I'm just going to show you again. If you square -3, you get 9. If square -1, you get 1. So you need to change the position because it does not make sense to have sin x minus 2 greater or equal than 9 and less than or equal than 1, right? So you change the position. Okay, so from here you can see that the maximum value, okay, there's a square here. So the maximum value for this is 9, right? So you need to add to the 3 because we're finding for this. So mustn't forget your 3 there. So 9 plus 3 will give you 12. That's the maximum value. Then the minimum value will be 3 plus 1 gives you 4. Okay, so that's it for these questions, right? And this is the last questions for the whole assignment. Okay, thank you very much.